Hello, my name is DB Schmidt, and I'm one of the TAs for 184 this semester, and I will be doing all of the discussion walkthroughs. So normally how these are going to go is I will have one video per question on the worksheet, and we'll put it all in a playlist for you, and you can go and watch whichever videos you want. For this discussion, since it's a little bit different, I'll be going through lecture review in this video. And then in the next video, I will go over some setup if you have a MacBook. Okay, now for some lecture review. So far we've talked about rasterization, which is turning some sort of continuous function into a form that you can display on an actual screen. So in order to display something on a screen, we need to discretize our continuous function through what we call sampling. One way to do this is to go through every pixel on the screen and perform a point and triangle test. And if your pixel is in the triangle, then you would color it whatever color the triangle is, and if it's not, then you don't do anything to it. So, how do we actually perform this test? So here, I'll go through a little bit of the math for performing this point in triangle test, but you should probably rewatch the lecture if you want to go through the whole derivation of this test. So just a brief overview of it is we take a triangle and we look at each line, each side of the triangle, and perform this line equation test on each side of the triangle. So what is this line test? Well, we look at a specific line, say P0 to P1, and if our pixel is above this line, or below, depending on what kind of line it is, then we know that the pixel is not in the triangle, or it could be in the triangle. So how do we determine which side of the line this pixel is at? We perform this line equation test. So that's down here on the bottom right. Give it a second to uncover, but essentially we just compute this formula, and then based on the sign of your answer, so if the value that you get is greater than 0, then it's above the line, and if it's smaller than 0, then that means that it's below the line. So then we perform the same test I just described for every side of the triangle, as you can see here, and then if your pixel is on the correct side of the line for all three of these tests, then it is inside the triangle. If it fails one of these tests, then you know that it is not in the triangle. Okay, so then you just repeat this for every pixel on your screen, and you get something that looks like this. It looks kind of like a triangle. So there's one more thing that we learned about in lecture, and that is about these jaggies. So jaggies are these kind of staircase looking edges that you get from aliasing. So what is aliasing? Aliasing comes about when we have a high frequency signal, such as a continuous line, and we undersample it. So the samples poses a lower frequency signal, which acts like an alias for the higher frequency signal, which is kind of how this term comes about. So the way to avoid this is to increase your sampling. And if you increase your sampling enough, then you can accurately represent your high frequency signal, and you will no longer have aliasing. So in order to actually determine how much sampling we need to do in order to correctly represent our signal, we have the Nyquist theorem here. And that is defined as we get no aliasing from frequencies in the signal that are less than the Nyquist frequency. And the Nyquist frequency is defined as half of the sampling frequency. So that'll tell you pretty much when you will have aliasing and when you won't have aliasing. And so this is really great because you will know like to which point do you need to increase your sampling in order to accurately represent the signal that you're trying to represent. Okay, and then that is it for the lecture review. And then in the next video, I will go through some setup instructions. Thank you.